Okay, let's continue looking at this regression analysis. And in the last video, I said I didn't remember what f and significant f was because we don't use ANOVA a bit in here. What f is a measure of whether or not our null hypothesis is incorrect, and significant f is talking about our p-values. So obviously we want these numbers to be low, but once again, we typically do not worry about the ANOVA side of things. We're going to look at the regression statistics and the p-value. So, all of our variables are good. Everything's fine. The p-value is less than 0.5. We can now write our regression equation. And so our regression equation is going to be the total production cost is going to be equal to, this is going to be in dollars, not zero. It's going to be equal to 20,261.27 plus 12.80, and once again, this is dollars, times units A plus $17.69 times units B plus $15, put the dollar sign in, $15.23 times units C, where units A is the number of units that we make of A a month, units B is B, units C is C. So that is our regression equation. We're going to use that here in a second to solve this. But let's talk about the interpretation first. So the intercept. So for the intercept is the total production cost when we produce no units of A, B, or C. So in this case, because we're talking about a factory and we're talking about costs and units being supplied, that intercept is going to be equivalent to our fixed cost. Now this is not always the case with the regression. Sometimes the intercept is just the intercept, it doesn't mean anything, but in this case it does. The intercept will be our fixed cost. And so what about the slopes? Well, the slopes are our variable cost for each different unit. Because if we produce 100 of unit A, well, that's going to be 12.8 times 100. So those are our variable costs. So this is really great when you have something set up like this because you can back work out what your fixed and variable costs are going to be. And so let's use the regression equation and predict what our total costs are. So total cost, total production cost, that's our Y. And that's going to equal our intercept. We are going to, in fact, let's just slap down range names really quick. So create from selection, left column, because we're going to have to lock it in anyway, and it'll be a little bit easier to see the equation. So we've got the intercept plus whatever we're making of unit A's times unit A plus whatever we're making for unit B. Since it's all hidden, I just use the right arrow to move it over to C18 times the slope for unit B plus, and once again the right arrow to get over one at D18 times unit C. And so now if I hit enter, we can see that that's what we're multiplying together. And so we've predicted that month 16 is going to be 45,000. I can just drag that down. And month 17 is going to be 44,098. And so that is those are the things that we have going on. Now let's go back to that regression analysis tab really quickly, and we're going to change a couple things. Now I'm going to leave everything the same, except I want to take a look at my residuals and my normal probability plot. And let's take a look at what those are and what they're going to talk about. And so I'm just going to drop it in the same place, so everything that we've written is going to go away. If you want to keep this, change the range output to somewhere else. But I'm just about to, I'm going to just drop it in the same spot, say okay, okay. And so now what happens is it just rewrote in the same spot. I'm going to move the probability plot down here, and we'll talk about this in a second. Okay, first of all, we've got the residual output. What is a residual? So a residual is, I'll put the definition, let's put it down here. So the residual is going to equal the actual data minus the fitted data. So basically how far the data is off. And so it calculated it for us, and it goes, okay, well, this is the predicted, because if we went back through, and so let's do that. I'm going to, and we'll just fix it. I'm going to move this regression equation up here. We'll have to fix some stuff. So units A is going to be here. That's units B, it's here, and then units C. Okay, so we grabbed all that. Now this gray column here, so this is what the total cost was. This is what our regression equation would have predicted the total cost to be. So there's going to be a difference in there because we're curve fitting data, and that's what the residual is. And you'll notice that predicted cost $57,291. I did that off the regression equation. I didn't need to do that because it will calculate it from the regression equation here. And the residual will tell me how much that is off by. And this is what we would use to calculate out mean absolute deviation, mean absolute percentage error. So that's what we've got going on here. So this other side, this one's a little bit more interesting. This is our probability plot. Well, because we're talking about the probability of something happening. Now you notice that when we came in here, some of the stuff that we got was this lower and upper 95. What is this talking about? Well, this lower and upper 95 here is the 95% confidence interval for the coefficient. And the second one here is going to be tagged to, I think it was the standard error. I'm not actually for the second one. Once again, I don't remember. And why do I not remember this right off the top of my head? Because we typically don't use this a lot. I'd have to go look it up again because we really are looking for the p-value. I mean, we all know what standard error is. We've been calculating that out. We all know what t-stat is because we've been calculating that out. And these are our confidence intervals. The first one, like I said, I know is for the coefficient. I forget what the second one is for, but once again, it doesn't matter. But just in context of the whole conversation, that means that this coefficient, which we've got tagged at 15.22, well, we're 95% sure it's somewhere between 10.06 and 20.39. So, depending on probability, things are going to change. That's going to change our regression equation. So what we can do is we look at our probability output. And so basically this is just giving us a way of measuring what the cost would end up being using a, well, kind of a, it's a distribution sort of, but it's not like we've got the Gaussian or the normal distribution or whatnot. But it's telling us that there's a the 60th percentile. Well, if we go over here, well, 63rd percentile, the total cost is $46,731. So that means 63% of all of the variations are going to be at 46,731 or less. And we can run that up to the 96.66 percentile. This stuff is interesting. Typically, we're not looking at this stuff, but I did want to show it to you. And so for us, the most important things are going to be R squared and those p-values. So once again, let's highlight those, just so we can remember those R squared and those p-values. Because once we check those out and everything's good, then we go right to the coefficients, which is where we're going to build our regression equation. And that is the end of our first simple regression problem. Now, as I said, what can happen is some of these data points might not be good. We're removing columns, and that'll happen when we have bigger data. But as for right now, that's what we have. So if you have any questions, please let me know. Otherwise, I will see you in the next video.